ratios to show how likely or unlikely an outcome will be. The ratio is called the probability of the event. It is expressed as the top number, the number of successful outcomes, and the total number over the total number of outcomes in the sample space. If you think about this tied to when you get a test back and you get 7 over 10, that means you were successful on 7 out of 10 possible points. So it's a similar situation you've been dealing with in school for years. The idea of what you did right out of how many there were possible. Same thing here. The number of successful outcomes out of the total possible outcomes. Okay? The numerator is the number of elements in the sample space that meet the desired criteria. So NA reads the number of outcomes of event A. And the denominator is the possible. So NS, the number of outcomes in the sample space S. So the probability of getting ahead on a single flip of a coin is going to be 1 over 2. So there's one head on a coin, and there's 2 possibilities. The probability of getting a red marble from a bag of 3 red and 2 blue, well, how many red marbles are there? 3. How many marbles are there in the bag? 5. So it's a 3 over 5, 3 out of 5. The probability of 5 on a single roll of a die is, okay, yes, it says number 5, but how many of them are there? There are 1. How many sides of a die are there? 6. So you have a 1 in 6 chance of getting a 5 on one roll. Now we use this notation, P parentheses A, to represent the probability of event A. So to notate the previous examples, it would look like, hold on here, need to add this. So the probability of A equals number A over number S for the sample space. So that's just putting all that terminology from before together. So what would it look like with what we just did? Well, probability of getting heads would be 1 out of 2. Probability of a red marble is 3 over 5. And the probability of rolling a 5 is 1 out of 6. So that's how you write it, an actual event, using all the new terminology. Now, ratios are most often expressed in the form of fraction. Fractions, however, can be expressed as decimals or percent. So probabilities may also be expressed as fractions, decimals, or percents. So the range of values for a probability is from 0 to 1. To have a probability of 0 means that it is impossible for it to occur. So it is not possible. So if I have a bag, well, let's see, for the event to happen, such as picking a red marble from a bag of 7 blue and 3 white. It's impossible. If there's only blue and white in the bag, you cannot get a red. So there's your chance of 0. To have probability of 1 means that it is a certain event. It will happen. Such as picking an even number tile from a bag containing the tiles 2, 4, 6, and 12. If those are the only numbers in there and they're all even, you are guaranteed to pull out an even number. So as the chart on the left shows, probabilities range from 0 to 1, from here to here. If it's not going to occur, it's 0. If it will occur, it's 1, and then it's in between. So you have everywhere from impossible to certain. So 0.25, unlikely. 0.5, equally likely. That's why you hear people say you got a 50-50 chance. 0.75, very more likely. So, an 8-sided die is rolled, and the outcome is noted. Determine whether each of the following outcomes is certain to happen, certain not to happen, likely or unlikely. So, getting a 3. Okay. Well, if you're only trying to get for one number, that's a 1 out of 8 chance. Now, there's a chance, so it's not going to happen. It's just unlikely. Not really good odds. Getting a number greater than 3. Well, that's 5 over 8. That's better than halfway. So it's likely to happen. So go back to here. If you think about it, we talked about how these can also be written as decimals or percentages. You know, so this is a 25% chance, 50% chance, 75% chance. So better than 50 is likely. Less than 50 is unlikely. So if you think about it, 1 out of 8, you turn it into a decimal, 8.125, unlikely. 5 out of 8, you just got to think about halfway, which would be 4/8. So it's greater than that. Not much, but greater than 50%. So there you go. Getting a value less than 10. That's certain. If the numbers are 1 through 8, you will get a number less than 10. How about getting a 12? Not going to happen. It's impossible. Okay, determine if the events are impossible, unlikely, equally likely, likely, or certain. Getting a red on the 4-color spinner. Well, you can get a red, but since it's much smaller than yellow, it's unlikely. You have a much better chance of getting yellow or blue, because that's 3/4 of it right there. If you think about it, yellow is half, blue is a quarter, so this is half, this is a fourth, which means each of these is 1/8 of a chance. So it's unlikely. Rolling this die and getting a value greater than 1. Well, you can't say certain because of this, but it is likely. You have a pretty good chance. There's 1, 2, 3, 4, 5 chances out of 6. That's pretty good odds. Selecting a football from these objects. Well, that's impossible because there are no footballs there. Determine the basic probability. In a bag of 1 red, 4 green, 5 green, and 4 yellow. Well, the first thing you want to do is total these, always, your first step. So there's 10 marbles. That's always a good first step. Find your total. Now, probability of yellow, there are 4 yellows out of 10 total. A colored marble, well, they're all colored, so that's a 10 out of 10 chance. A green, there are 5 green out of 10 marbles. Okay, in a standard deck of cards, remember there's 52 cards. There's 13 of each suit. Remember that from lesson 1. So a spade, we talked about it in lesson 1. How many of each of these are there? There's 13 of each suit. Remember, 52 divided by 4. So that's 13 out of 52. An 8 of hearts. Well, there's only 1 8 of hearts. Now, if it said probability of an 8, there's 4 of those. So 4 out of 52. And remember, in statistics, you don't have to reduce. I can't say remember, I haven't told you this yet, but you don't ever have to reduce. You can leave them as non-reduced fractions. Okay, a jack. Well, there are 4 jacks out of 52. You do not have to reduce that to 1 out of 13. You can leave it 4 over 52. Okay, with this die, there's a 1, 2 2s, 2 3s, and a 4. So again, there's 6 chances. 6 numbers, whatever you want to think about it as. Probability of a 3, well, there's 2 of them. out of 6. Probability of 4, there's 1 out of 6. The probability of not getting a 2, that is 4 out of 6. And that's it.